Hello there. As a solutions engineer with Bugtech, I get to talk about some really cool technology. And today, we're going to talk about an invisible force that can literally make or break your most critical equipment: vibration. We're going to explore how we can monitor it, not just as a science, but as an art, to keep everything from your pumps and fans to entire production lines running perfectly. Just think about that for a second. What if your most valuable machines, the ones that you absolutely cannot afford to have go down, what if they could just raise a hand and say, hey, I'm gonna need some maintenance next Tuesday? It sounds a bit like science fiction, right? But it's not. It's the reality of what we call predictive maintenance.
Okay, so a little shaking, what's the big deal? Every machine with moving parts is going to vibrate. That's totally normal. But the moment that vibration starts to change, that's when it becomes the very first symptom of a deeper problem. It's a huge, unseen risk that if you ignore it, leads straight to surprise failures and, you guessed it, really expensive downtime.
So here's the key takeaway, the big idea. A machine's vibration, well, it's its voice. It's the language it uses to tell you how it's feeling. When a bearing starts to wear out or a shaft gets misaligned, that changes the machine's tune. It creates a unique vibration signature. And if you can learn to speak that language, you can diagnose what's wrong with incredible precision.
So, how do we translate this machine language? This is where we stop guessing and start using science. And the best part is, this isn't some secret formula that only we have. It's a methodology that's built on internationally recognized standards, which means anyone can use it to get results they can actually trust.
Now, I know what you're thinking. This looks like a really dense technical document, but don't worry about reading the fine print. What's important is what this represents. This is an international standard called ISO 10816. You can think of it as the official global rulebook for measuring and evaluating machine vibration. It ensures that your analysis is credible and consistent, no matter where you are in the world. And what this standard gives us is our most important metric. It's called vibration severity. It's not just some random number. It's a single, really powerful value that boils down all that complex shaking into one easy-to-understand health score for your machine. All right, that all sounds great in theory, but how does it actually work on the factory floor? Well, setting up a full-blown monitoring solution is actually pretty straightforward. We can break it down into 5 logical steps, taking you from the sensor on the machine all the way to the data in your hand. So it all starts with step 1, the sensor. This is like a stethoscope that you attach right to the machine. Step 2, that signal has to travel through a cable, which is chosen for that specific environment. Step 3 is the mounting hardware, how you attach it. Then step 4, an enclosure, which acts as a safe central junction box. And finally, step 5, the instrumentation, which is the brain of the operation that actually reads and analyzes everything. Each step is a critical link in the chain. Of course, you can't just use any old sensor. You've got to match the tool to the job. For most of your standard equipment, a general-purpose sensor is the perfect workhorse. But what if you're dealing with a really harsh environment, like a high-temperature kiln or a dryer section? Well, for that, you're going to need a specialized sensor that can, take the heat and still give you a perfect reading.
Okay, so once you have the right sensors, you need a strategy. You've really got 2 main paths. The first is a permanent installation. This is the gold standard, especially for your most critical machines. The data is super reliable, and you can access it remotely, which is a huge safety win. The other path is walk-around monitoring. It costs less upfront, and it's flexible, which makes it a great choice for your less critical assets.
And believe it or not, how you attach that sensor is a really big deal. Just look at these 2 methods. On the left, you see a permanent stud mount. It's physically bolted to the machine. That gives you the cleanest, most trustworthy data, period. On the right, you see a magnetic base, which is great for those quick walk-around checks. The bottom line here is simple. A better connection always means better data.
Okay, so you've set up your system, you're collecting all this data, you've got numbers, charts, now what? What do you actually do with it? Well, this is where that ISO standard we talked about becomes so incredibly powerful. It gives you a simple framework to turn all those raw numbers into clear, actionable decisions. Think of this chart as your official decoder ring. Seriously,
This standard simplifies everything into 4 simple color-coded zones. All you do is take your machine's vibration severity number, find where it lands on this chart, and bam, you instantly know its condition and what you need to do next. Let's break it down really quick. First up is Zone A, which is green. This is your happy place. This is the ideal state. It's what you'd see from a brand new machine right after installation or one that's just been overhauled. It's the benchmark for perfect health.
Next, we have Zone B, yellow. This is the satisfactory range. Honestly, this is where most of your healthy equipment is going to live its day-to-day life. It's running fine, it's good for the long haul, no action needed.
Now we get to Zone C, orange. Okay, this is your first real warning sign. Think of this as the alarm level. A machine in this zone is telling you something's wrong. It's not safe for long-term operation anymore, and it's time to schedule a repair before it gets a whole lot worse.
And finally, we have Zone D, red. This is the danger zone. This is your critical TIRP level. The vibration here is so severe that it's actively damaging the machine and could lead to a catastrophic failure. Action is needed right now, and that almost always means an immediate safe shutdown.
So, we've gone through the problem, the science, the step-by-step solution, but let's zoom out. What's the real big picture benefit of all this? This is what we call the predictive advantage, and it's a total game changer. The payoff is it's huge. Instead of constantly reacting to failures, you see them coming weeks or even months in advance. That means less unscheduled downtime, for sure. It means your people are safer, because they're not rushing through emergency repairs. It means you stop wasting money on routine maintenance you don't even need. And you make your most expensive assets last so much longer. It's a fundamental shift from being reactive to being proactive. So, I'll just leave you with this final thought. Right now, at this very moment, your machines are talking. They're constantly communicating through the language of vibration. The tools, the standards, everything you need to understand them is out there. The only question left is, are you listening?